Hello, everyone. I'm going to talk about the neural network emulators that we are developing in Barcelona for the Lyman Alpha Forest, together with Jonas Chavez Montero and Andreu Font Rivera. So as probably most of you already know, the Lyman Alpha Forest is a series of absorption lines that are in the spectra of distant quasars due to the absorption of light caused by the neutral hydrogen present in the intergalactic medium. So one way of doing cosmology from the Lyman Alpha Forest is to measure the correlations along the line of sight of individual quasars, which is also called the P1D. But to do so requires very expensive hydrodynamical simulations because we need to be resolved to very small scales. And therefore, we need emulators for the cosmological inference. So in Barcelona, we are developing what we call the laser emulators, which predict the P1D as a function of the amplitude and slope of the linear matter power spectrum, together with other parameters describing the IGM. So I guess the question is, what makes LACE different to other emulators? So first of all, since we are emulating as a function of amplitude and slope of the linear matter power spectrum, we are not explicitly including any redshift information. And therefore, we can emulate the P1D at any redshift, even if it's not represented in the training sample. This is very important because this enables later the analysis of data with any redshift binning. So for instance, in the plot that I'm showing here, for instance, for redshift 3, what we did is to take all our training simulations, drop snapshots at redshift 3, and then predict the P1D at redshift 3. And we can see that the emulator still reaches a sub% accuracy, even if it has never seen snapshots at redshift 3. Another achievement of the LACE emulator is that it can predict cosmologies that are not represented in the training sample. So what we did here is to take our training simulations, train the emulator, and then test it on cosmologies with different growth rate, with massive neutrinos, with running of the spectral index. And in all cases, we were also reaching a sub% accuracy. We also did a more challenging test where we were testing our emulator on simulations with different thermal history, which is, for instance, this thermal history here in red in the plot. And in this case, we were not reaching the sub% accuracy, but we still had less than 2% error, which is a good result for given the difficulty of the test. So what's next? Now we are working on another emulator that is a normalizing flow, mapping the same parameters to the P1D and the P3D simultaneously. So if you're interested and you want to talk, please via Slack, or I'll be in the coffee breaks. Thank you.
Great, thanks.